So I picked up this cheap Juice Bank portable power for mobile devices. Says it's 4400 milliamp hours, comes with a 30 centimeter charging lead. All looks good. Battery specs on the back there. I think you should be able to read that. Battery is 2200 milliamp hours, but the total power is 4400 milliamp hours. But it says 2200 by 2. So based on that, I'm guessing it's probably, in the shape of it, it's probably got two 18650s in it. Input 1 amp, output 1 amp, one USB socket. Short circuit protection, overcharge protection, over discharge protection, overcharging protection. Anti-memory, well, if it's lithium, it's going to have that anyway. Mobile phone and iPad charging, although only being 1 amp, you're not going to charge your iPads or your modern phones too quickly. So let's have a look at it. There's that lead that it comes with. Looks like a pretty standard micro USB cable. Doesn't feel too bad, doesn't feel too flimsy. It'd certainly do the trick by the look of it. Yeah, by the shape of that, it certainly looks like a pair of 18650s, doesn't it? So, let's... okay, so it doesn't have a power switch. Some of these things has a power switch to activate the circuit. That's probably why on here it does say charge at least every 3 months when not in use. I'd say the supply circuit doesn't really quite turn off. It's probably just waiting for sensing for an output. So let's see what happens. I don't even know how old this is or how long since it's been charged. Okay, a blue light came on, so it sensed the output. And straight away we've got 5.11 volts. So let's load this thing up and let's see how much power it can give us. Alright, let's just slowly crank this up. So 0.7 already. We're still holding at 5 volts. And so that's what it's rated for on the packet. So it's still holding at 5 volts at 1 amp. So right now it's holding up to its own specification. Let's see how much further we can push it before the voltage starts dropping off. Oh, yep, 4.9 volts at 1.3. 4.8, 4.7, 4.5, and she shut off. Alright, so that looks like it's its cut-off mark. So you could pull 1.45 amps out of it, but it's dropped down to 4.7 volts. Let's see on the fine adjustment how cheeky we can get. 4.8, would 1.49. So you can squeeze 1.5 out of it, but soon after that, it's dropped down to 4.5 volts now anyway, so it's obviously out of its rating. But if I drop that down to 1.1 amps, it's back down to 5 volts straight away. So it exceeds its it certainly exceeds its recommended capacity on the packet. So let's pull it apart and we'll see what it does. I've got to pull it apart off camera, but hey, nothing like pulling apart something that's got live electricity on camera. I was just thinking about this and looking at it. It's a very basic unit, to the point that most of these units even have a battery level indicator or anything. This is plain. It's got nothing, just in, out, and battery level indicator. Now, I can only assume that either I'll pop that off or something under the label. Let's try taking the label off and go from there. It's always fun with live batteries. Sticking metal objects in, see what happens. I've seen those nice ceramic knives. Oh, they're not a bad idea for prying into something unknown. So under there is just generic plastic molding. So this is a nice pretty sticker, but underneath is just a label. That doesn't look like that comes apart at all. No, that's all solid at that end. So obviously this end must come out. That wasn't too bad. Sure enough, look at that. So they might be glued in, so they might be a bit more fun. As you can tell here, you've got your small charging circuit and two 18650s in there. Now I'd love to pull them out, but I'm just not sure how that's going to go. Rather not break it. I'd rather keep it working. I just don't know if those batteries are going to come out very easily. They've probably put double-sided tape or some kind of glue down it or something like that. But yeah, circuit board is 080-1 version 2.0. Pretty straightforward, battery in. So I'm sure this has some kind of BMS on it. I'll see if you can read the chip at all. See, I can't read the chip without magnifying it a bit. I'll read the chip, I'll find out about it and let you know in a second. So, I had a bit of a look around on the internet. Can't find anything about it, but looks like the main controller chip is a hot chip, which I've never heard of before. A PB0065E. Don't know whether anyone else has come across it before, but it's going to be pretty obvious to be a voltage regulator and charging chip. Surely it has a bit of protection, and hopefully that's straightforward as that. Like, there's very little to it. There's a couple of other chips on the side. They may be for balancing or part of the battery protection, I'm not sure. Now let's see if I can pull this apart without shorting something out. Should be interesting. Okay, so that was just a little bit of insulation on top. And this is the whole negative side of both of the batteries. So let's see if I can. There you go, that's not so bad. That wasn't too bad at all. So it wasn't glued in. It's just a tight fit. So, look at that. 18650, 3.7 volts, 2200 milliamp hours, which is exactly what it said on the packet. So the packet was correct. 2 by 2200 milliamp hour batteries. So it's good to see, you know, cheap battery pack actually holding up to it's doing what it says it will. Has in it what it says it. They are in parallel, so sure enough, yeah, that'll give you 4400. That's at 3.7 volts though, so that's not at 5 volts, so you're not going to get as much as what they make it claim, but it's not unlike these things to boost their claim. Now I'm going to give this a review. Let's see. 3.8 volts, so down a bit, but not fully charged. I've had this for a few weeks, and I haven't done anything. I haven't pulled it apart or tested it. I haven't charged it, as you saw earlier. I pulled it out of the box. I don't know how long it's been sitting on the shelf for, but at this point, it doesn't look too bad. Yeah, so yeah, it's a handy little jigger. So it certainly looks like it'll perform fine. It's a fairly standard size board on there. I don't think it'd be underrated at all. It's only rated at 1 amp. And the batteries do have on them, printed on them, what it says on the box. So in all, it's nice to have what it says on the box sometimes. So at a basic look, it is what it says on the box. It was cheap. I would recommend buying one if you wanted just a small one. The only thing is, obviously, that 4400 milliamp hours is not what you'll get at 5 volts, because that's going to have to upconvert that, being only a 3.7 volt batteries in parallel at 4400 milliamp hours. But you certainly get a good chunk of your phone charged out of this, if not all of your phone, depending on how big your phone battery is. So just had a little bit of a play with this. As you can tell, there's no LED on the board at the moment. Plugging it on, LED turns on, throw some load in it, and the way it goes. Interesting, because I've already got this meter, this load loaded up at near its maximum capacity. The meter did turn off for a second going on, so it's probably the output circuit balancing itself. But notice that light stays on. So if I just take the load off it, sensor light does stay on for a little bit longer, and then it does shut off. So obviously it is shutting off its converter circuit, so that's good. It's not wasting electricity in that, and I'd say it's got some kind of sense circuit in it just to, there you go, it's just turned off. It's obviously sensing when something's plugged in and not, so it'll be like a lot of those different units that if you just pull a very minimal amount of power, it probably won't turn on. But in the day, if you're charging your phone or anything like that, you'll pull enough power to turn it on. So yeah, the unit looks pretty good. So I thought I'd do one more test. So I've got my power meter here. I've got the 5 volt power meter here hooked into the battery pack. Just getting it all on camera. And this battery pack is easily rated at 2.6 amps. It'll hold its voltage at 2.6 amps, even though it's only rated for 2 amps. So I'm confident with it. This only is supposed to pull 1 amp at charging. So let's fire it up and let's see how much it pulls charging. So already right away we're pulling 6.65 watts. And that's pretty accurate. So it's charging at 0.997 of an amp. So on the box it says it'll charge at 1 amp. Can't complain about that. 0.997, 0.998 amps at 5 volts. So quite accurate. I'm not going to be splitting hairs over the fraction of an amp it's under that. It'll certainly do the trick, and it does what it says on the box. That's the most important thing. So I've been doing a battery test on this. Well, I'm going to do a battery test. First I'm discharging it. And I just want to show this because it's starting to do it. So I'd say this is flat now. The battery's flashing. And there you go. That's just shut off. That was good timing just to catch that. So the battery started flashing on the battery pack right here, and it's now shut off. So the next thing I need to do, turn the lights back on. Next thing I need to do is charge it up, and I'll measure with this little meter to see how much power it takes, to see whether the rating of this unit is what it's claimed to be. So starting to charge this up, and we'll see what happens. So this charge has dropped down to 4.8 amps. I don't want to use my big one because I don't want to overstress the charging on this. So only running something that's rated 1000 milliamps. It's running 99.48. That's not too bad. 4.8 volts, close enough. We'll charge this pack up and we'll see how many milliamp hours it takes once it's fully charged. So this battery bank is fully charged now. As you can see, we've put 2,564 milliamps in it. Couldn't even see it from this angle. So it's that's about all it seems to hold. Next I'll do a discharge test and we'll see what happens. Alright, this pack has turned itself off. I thought that I was going to be able to, thought it may have just recovered just a bit to turn itself on. But apparently not, so I'll just find another transformer and then I'll plug it in. This little unit remembers where it was sitting on last as far as amp usage used, so I'll just grab this one and we'll see where it's at. Keep it on screen. So we've got 2,687 milliamp hours. So definitely not what it said on the packet. So that's really the only downside of this little thing, really. It'd be fun to actually find if anyone did actually have the same amount. It's saying total power 4,400 milliamp hours. 2,600 is not 4,400. As it says right there in the box, 4,400. Certainly not the case. But now we know.